Hi, and welcome to this lecture on classes. In this lecture, we're going to learn about what classes are, attributes, methods, inheritance, special methods, and some common errors. So, I've got a lot to get through in this lecture, so I'll try to not rush, but we'll try to get through it very cleanly. Let's open up our script editor and get started. In your viewport, click and hold spacebar, panels, and then go down to panel, then go up to script editor, fifth up from the bottom. And also make sure that you have line numbers in errors ticked on and show stack trace ticked on. And clear the top output. So, what are classes? In Python, a class is a blueprint for creating objects. It defines a set of attributes and methods, and that all objects of this class will have. Here's an overview of the key concepts in Python classes that we need for our Maya setup and our nodal system that we're going to be creating and we will work on in this project. We're going to touch on pretty much everything you'll need, but that little bit more that we're going to go into later in much more detail. So let's have a little look at attributes. Attributes are variables, essentially, that belong to a class or in an object. So they are thought of as the properties and characteristics of that object. You can define these attributes in a class using the init method, which stands for initiate, which is called when an object is created. So here's a little example. We've got our class, okay, car. We are defining and initiating essentially this class when we create it. And this class takes self, which represents this whole class. That is an instance of the class itself. We'll talk about that more in detail later. This takes make, model, and year. Once we have essentially passed these, we're going to assign to self, to the instance of this whole class, we're going to assign self.make. So using our dot notation, we're essentially saying that car.make will be the make we've passed, model will be the model we've passed, and the year will be the year that we've passed. We can then add this to a variable, which stores the instance of our class. We can pass it a type of Toyota, a Corolla, and year 2022. And then we can print mycar.make. So let's do that. And we get Toyota. So you see, very quickly, we get some pretty cool functionality that we've now are able to call different properties of our class type. So again, this init method, when we create the class, okay, this is called on initiating the class, okay, on this instance being created, okay, the first thing the class will do is look for an initiate method. And if it does find that, it'll say, okay, well, do we take some arguments? And if we do, these will be essentially passed and dealt with in whatever way possible. Again, if you pass these arguments, but you didn't have anything to take them in here, you would just get an error. Okay, you've not passed anything to it, but this class is requesting it. Or you can make these keyword arguments and pass them defaults. So, all right, let's have a little look at a little bit more detail of what these double underscores mean. So these double leading and trailing underscores here, these are also called dunder and magic methods. They're reserved for methods that have special meanings in Python, which we're going to look at a lot more here. For example, init is a special method that is called when an object is created, as we've just shown. You've got double underscore string or str, okay? And this is a special method that is called when an object is converted to a string. Okay, these special methods are used to implement operator overloading, object comparison, and other advanced features in Python that we are going to go into heavily. So again, like if you wanted to add a car to another, well, how would that act? Okay, can this class accept a plus? Because at the minute it doesn't have the special method that allows it, but we're going to go into that later. And trust me, it's awesome. This is what I love about Python so much. I won't jump ahead too much. So we've got methods. Let's have a little look at these. So what's a method? Methods are functions that belong to a class or an object. And they can be used to modify the attributes of an object or perform a certain functionality or action related to the object. So you can define methods in a class using the same syntax. Let's have a little look here. So let's say we go back to using our class method, okay, that we had with car. Okay, we've got make, model, year, but now we've got a little method that's description, and we're using our f string, which is then going to print out, again, self being the instance of the class, the self.make, self.model, self.year. So let's see what this does for us. And we'll see how we call it. Print my car dot description. So using dot notation, again, we're accessing some more cool functionality. But as this is a method, remember we always call methods with our parentheses. So this is a Toyota Corolla 22. So we've got, again, Toyota with a space, Corolla with a space, open parentheses within the text. Then, okay, self.year. So, and that is printed out exactly as it is here, perfectly. In this example, we're defining the method, we're defining the class again. We're creating an instance of the class, assigning it to my variable, or sorry, my car, the variable my car. And then we're passing it the Toyota Corolla 22. This has got a make, a model, a year, and these are attributes of the object. Right? Now, then using dot notation, we're able to access both these, but we're also able to access the description. Now let's have a quick look at maybe private variables and methods. Now, we've used double underscores, and so these are here to use magic methods, okay, or have some more built-in functionality with Python. But, okay, what is a private kind of example of this? So what's a private variable, a private method? Well, so private variables and methods, they are still allowed in Python. They're not treated as some other programming languages would treat them, but they are single underscores, and these indicate the intended purpose, essentially, of these variables, okay, or these methods. And they show that they are intended to be private and that they shouldn't be accessed from outside the class. So let's say you've passed this information, you've passed your make, model, and year to the class, but you actually don't want it to be accessed by a developer, okay, directly. You might have a series of methods and a series of different functionality created so that they can get that information. But let's say you don't want them to do it directly. So, okay, let's create our class. Let's create our new class. Let's override our car method, okay, our car class with this new car. And now what we've got, again, is the underscore and everything. And we've got this underscore on the method here, so signaling that this is actually a private method. And what we're going to call is description. This hasn't got an underscore at the start, so it's actually showing that this is not a private method. So we probably should call this, and then this will provide us back this get information. Bound method. What am I doing here? So we didn't put in parentheses. My mistake. Okay, we didn't call this we didn't call the method. So again, we're calling the instance of the class, and then we're saying from that class, call get information method. Okay, but we didn't put the brackets in, so it didn't work. So again, we've called this description method, which is then within the class is called the private functionality, the private method of get information. Now, this can be useful within certain connotations, but it's you've just got to remember that calling private variables is still allowed. The single underscore is literally only indicating that they are intended for private purposes. And you won't be using it too much, possibly within, it's used a bit more within app development and within functions that, okay, are only meant to be used within certain key structures, essentially. So let's, how can I explain this maybe a bit more? So it's basically, a single leading underscore before a variable. This is showing that the variable is intended by convention, or is indicated to be a private variable or a method, as we're seeing here. It's not enforced by Python, as I've said, so Python will not enforce this. Unlike other languages, I believe Java, again, you cannot call these functions from outside the class if they have an underscore, but in Python you can, and it's widely used as a convention that just signals, again, to developers that this class, okay, has functionality which should not be accessed outside of it, and that there is another way to do it. Let's say you do need to call make, okay, constantly, or you're using it, okay, maybe it might be worth reading through the class, refactoring the code and going, actually, yeah, there's no point in this having it. So you would search all instances of the underscore make, rename it without the underscore. Sometimes, yeah, you will find these mistakes being made. Okay, people are trying to be smart. They're putting underscores on things they don't need, but you just might not need them. All right, let's move on. Let's have a little look at inheritance. Now, inheritance is an insanely cool thing, again, which is going to be very important for us going forward. Okay, inheritance is a way of creating a class that has a modified version of an existing class running it. So a new class called with the derived class or subclass inherits all of the attributes and methods of that original class. So calling a base class, or we can call this a base class or a superclass. So the subclass can then act or modify attributes and the methods as needed. And we are going to be using with our dependency node, our DAG node, and then our mesh nodes, our curve nodes, our joint nodes. They're all actually going to be inheritance in an inheritance hierarchy, okay, which will make them very powerful, trust me. Let's have a little look at an example. I'm going to have to zoom out just a little bit here. Let's clear our top window. Now, let's start right here. So in this example, we're going to define two classes. We've got vehicle and we've got car. Now, car, as you will see here, okay, is a subclass of vehicle, okay, which means it inherits all of the attributes and methods within vehicle. And then we can just essentially create new attributes. We can overwrite all the methods from vehicle. But at first, we are going to be taking them, okay, and we're going to reuse them, okay, to save us rewriting any more code, which is incredibly useful if you have lots of different types that you want to all have incredible functionality, as we're making, as I've shown essentially to you. Let's have a quick look through this. Now we've got our make, model, and year, and we've got our description. Okay, and then we've got our car, which essentially is inheriting this within the parentheses here. Now, because vehicle's not inheriting anything, doesn't need to have parentheses. The old convention used to be of typing object within there, but okay, we don't need to do that now. Within Python 3, I should say. Car, vehicle. Okay, so it's inheriting vehicle. That means, okay, it's going to take the same set of arguments, which is here, but you can add more to it, as we're seeing here. So what we're doing here is we're taking in the arguments, okay, and then we're essentially initiating the superclass by going the super, okay, using dot notation, accessing the initiate of our super subclass, and then passing it model, make, model, and year. And now, okay, we've done these two, this little bit within the initiate, and mainly this bit. Okay, we now have all the functionality over here. All right. So, but we also get self, okay, dot doors. So what you could do, you don't even need this section here. What you could do, okay, you could just print out this. Okay, you could remove that description, because if you now access car dot description, open parentheses, you will just get self.make model year. But if you want the description to also print out, okay, self.doors, what you can do, again, is you can access our superclass, which is our subclass, and you can go super, okay, dot description, okay, dot notation, accessing our description from our subclass, and then plus the f string self.doors. So what are the numbers of doors? This is quite useful because, again, it allows us to build on the functionality that's already been taken. And again, this might be like, well, why wouldn't you just write out this? Why not just copy this, put it in here, and save yourself doing that? Well, let's say you still want to make, let's say you want to make, certain subclass vehicles. You want to make a Tesla, you want to make a Toyota, you want to make a Ford. You want to use all these different, you want to have these different items, but you still might want to always change the base functionality that says make, model, year. You may want to change this for all of them and go, actually, yeah, make, model, and then or restructure this, reorder it essentially, but then that information wouldn't come through. So you want to be able to say super.description. This will allow you massive ability because it now allows you just to only make changes which are required within that subclass. So this is inheritance, and I'm hoping I'm explaining this clearly enough, because inheritance is amazing. The best way to put it is that it will cut down your code hugely, okay, if you learn to use this to work for you. So let's actually just print this out and see what happens. Well, so we've done print mycar.description, which again is now printing our description using the original superclass's description, the parent description within the hierarchy, and then adding this section with 4 doors. So we're now getting comma and itself.doors and doors. So you see, it's pretty awesome. I know that this is maybe a little bit complicated to look at, but these are essentially just a class. Okay, the only difference here from your normal methods that we've already learned about in the last lecture is that they are contained within this class. That you have your initiate, your init method, to start to add the variables to this class, and then from this you can now do all these descriptions. You can do any methods that you need. You can do description, you can do get car, you can set car, you can change things, you can do anything you want within this vehicle. So it becomes a very flexible object for you within your code. Special methods, or as we briefly touched on, magic methods in Python, for example, like init. Special methods, they're ones that have double underscores at the beginning and the end of their names. They are also called magic methods or dunder methods, short for double underscore methods, essentially. Okay, these methods are used to define special behaviors for classes, such as how they are created, compared, added, subtracted, or printed. All of these things, again, this is what these special methods do, and they all have defaults, or they all have default functionality. Okay, and if they don't, then you can essentially give it to them. That's the best thing about them. So here are some common special methods in Python classes. So please focus on these methods. They will be pivotal to our setups where you're going to use going forward, which will obviously make you a superstar Pythoneer. Okay, there's annoyingly not enough riggers know about these, and yet these are, like I've said, what will make you amazing. Initiate method. So this method is called when an object class is created. Okay, you don't have to, but again, this is what initiates those initial variables that you'll pass. Maybe if you don't have any variables that you need to pass initially, you don't need this. But it is used to initiate those objects, those initial attributes of the object. So, and the self parameter refers to the object being created and the instance of that object. So as we looked at here with our car class, okay, defining and initiating, okay, a class with our 3 attributes that are then being passed to the class-based attributes. All right, let's have a look at another one. So def underscore string. So as we said about string, this is going to define how, if this item is turned into a string, it is one. So if you do print and you say encapsulate this item as a string, let's say, okay, we initiate this. Okay, we add this to a variable, but now we want to actually kind of go, we'll call the description again. So let's say we'll use description instead for this. So this, if somebody then kind of says, actually, let's just do this for a minute. So we're only going to initiate the init. Okay, let's see what happens now if we print string. Okay, my car. So a string method, if you remember, built-in Python functionality that will turn an object to a string. Let's see what happens now. So let's just initiate, okay, our first bit of our class, highlighting, pressing Control and Enter. We will now, we've only got the 3 arguments in this version. We haven't used our inheritance. Go, okay, my car equals car Toyota Corolla 2022. Okay, print string. Okay, my car. And you see we're getting an object back because this is what default Maya is doing. It's just providing you with a string object, okay, with the object representation of our string. But that's not useful to you, essentially, as a human. But you may want to say, actually, let's give it something human readable that is useful for us to look at. And then go, okay, oh, indentation does not match. That's frustrating. Oh, it's definitely def here, isn't it? Okay. Let's make sure that does. So 2 and 2. There we go. There we go. Should work now. Okay. There we go. See, again, indentation. This is why I generally use an IDE when running code, because I don't really like using the built in my script editor. But okay, it's good for the purposes that you need to get used to it anyway, and you will be using it a lot. So okay, now let's print my string my car. Oh, that's not worked very well. There we go. It's because I've not initiated it, have I? So let's reinitiate. Sorry, again. Oh, very sorry. Silly here. See, again, I never really do it kind of this way when I'm working, but obviously this is what we need to do. We need to run the whole section. We've reassigned everything. This is our car class. And then we need to assign it to car because we still had our old instance of car assigned to the my car variable. So obviously then when we print it, the string method wasn't initiated when we created this. So it's still got the old object associated with it. So now if we go print, we get the string method has now given us this help and created that Toyota Corolla 2022. See, I like what I say about errors. They're very common. Okay. And yeah, like I said, this is my first time teaching, okay, all of these methods to you guys. So I'm going to probably make some silly errors here because, yeah, this is not how I write a class. If I'm creating a new class, I'll write it out in NIDE and I'll create these functionalities and the test essentially along with it to test it as I write. But yeah, you see, these are silly little errors that you'll be able to fix in no time. And that's actually quite important to know. Let's move on. Let's go to equals, I think, next. So equals. What is this doing? Now, this method is called when two objects are compared to each other using the equality operator. It should return true or false if the two objects are equal, okay, and, or false otherwise, okay, but again, it doesn't have to. This is, again, where you can start playing with Python and make it awesome. So as we're going to be doing later, and you've seen with my equals operators, within my nodal setup, this equality operator actually creates us a condition node because that's probably more important for us as Maya, within Maya. We actually want to compare if two situations are the same, not so much if two objects are the same. We can do that, but this isn't the way we're going to do that, okay? I can show you other ways of doing that, which we'll talk about later. But so this is our equality operator, and this is how you actually program it within Python. So you'll see equal. So you'll see the equal sign does not just mean that these classes or even classes of the same type, but these classes. But you can check if these classes are the same object with the same values that you're checking for. So the equality operator can be used for just so much. It is pretty good. Okay, so yeah, it can be used for so much. Let's have a quick look at what I mean by that. Let's have a look at our car class. Let's look at some more methods here. So we've got our car class now. And let's say, so is instance of other. So let's say we pass a method called other and is, okay, an instance of other car. And if it is, return is self.make the same as other.make, and is self.model the same as other.model. So you're going to guess hopefully you can guess what we can do here. If not, no problem. We're going to say, okay, initiate this, okay, class, and we're going to now also assign, okay, instances of car to car 1, car 2, car 3. So we've got a Toyota Corolla, got a Toyota 22, Toyota Corolla 22, and a Tesla Model Y, or Tesla Y 2022. So let's print now. Let's use our equality operator and see, okay, if car 1, okay, is the same as car 2. True, it is. Okay, we've returned true. Okay, and we have checked, pretty importantly, we've said, well, is the instance of car, is the car actual class the same as the other class? Okay, and what we've got with this equality operator, okay, so essentially we start off with our first car. So that becomes essentially our initiating object. And then this equality operator then passes my car 2 as the other and says, well, okay, let's compare these two items. So what we're doing here is we're checking, well, is instance other the same instance of car? Is it a part of the car class? And if it is, okay, then we'll start checking its attributes. We'll say, actually, well, okay, with dot notation, okay, is this is dot make the same as the other dot make? Is self dot model the same as other dot model? And so we're using, again, comparison operators here, just again check all of these. But obviously, if it wasn't even an instance of car, we just go with false. So if we go 1, 2, 3, false. 1, 2, 3 is not an instance of car. It's actually an integer. So it's not at all. So of course it's not. So we're using this already in a pretty cool way to check this. But let's say, okay, well, is it the same as, well, car 2 actually? Yeah, so we said that. Yeah, it's true. But how about car 3? False. Because now it would have gone through and it will have gone, yes, well, it is an instance of car, but the make is not the same. Okay, the model is not the same, but the year is the same. But that doesn't matter because we're using ands, we're not using ors. If all these were ors, then it wouldn't be. But yeah, they are. Okay, so let's have a look at another method. Another magic method, I should say. Okay, the repr, okay, or the repr. And now this is for representation, essentially, okay? This is a functionality called on an object, and it should return the string representation of that object, how it should be or how it can be recreated, okay? So that, again, is really going to be important for us going forward because we want to tell people, actually, well, how did you create this class, okay? Or what did it take for you to create this class with this information? So if you've got a series of joints which are being created, you want to say, well, to create this class-based object of this joint, it took, joint name this, okay, and this attribute and that attribute, and that's how it was created. So again, it's another magic method that it just gives us a lot of power. It's very useful for us, but let's have a quick look again of initiating or running it without initiating it. So let's first highlight and create my car with just the initiate, okay, with our attributes being added to it. We're not going to initiate the repr magic functionality, and we'll see what we get. So now let's create my car, okay, and then let's print repr my car. And you see, again, like we did with string, we get essentially just our main object, car, with the object ID, okay? This is the Pythonic ID, essentially, of this just code, okay? It's not useful to us. So what we want to do is we want to say, well, this is what was created. It was car, open brackets, self.make, comma, self.model, comma, self.year. This is the code that was used to create this. So it makes it very easy for everyone, okay, to actually recreate this setup. All right, so there we go. Okay, so we've initiated the whole class now. We've, highlighted all, press Control Enter, and you see then we've created our instance of car stored against my car variable, and it's Toyota Corolla 2022. Okay, and we print, okay, repr my car. This is what we get. We get the output of car, Toyota Corolla output, as seen here. And this is, again, essentially means that somebody can just quickly take that code, copy it, and recreate an instance of this object as it's needed. A really good little magic method there. Now, still getting cooler and cooler with the functionality. Again, as you've seen it, get item, get at are probably two of the coolest ones I've learned about. So these methods are used when an item is accessing using the square brackets notation on an object. It should return the value of the requested item. We're going to be mainly using this within the attribute section. So as we did with the material example within functions, okay, when I did material.a name of the function, that was the dot notation methodology, which is get atta, but this is the get item. So instead of doing a dot and then using the name there, we can do now dot a, so then open brackets and then write the string in text. Okay, and this is very important and really useful in certain and specific circumstances, which we will talk about. But let's have a little look at the example here. If you remember the example when I gave introducing you to the tutorial, this method is used to access attributes of an object to use. So it should return the value of the requested item, essentially, which is kind of like we're going to use going forward. So let's see if we can use an example here. So let's say we use a car. Okay, let's refunction this or repurpose this. We're going to use actually get item. Then we're going to say, well, Okay, so because we're using the actual names here, we're going to store these items within a dictionary. We're going to go self dot items equal dictionary. Actually, let's just do this dict, and we're going to go make equals make, which we know. Okay, and we're going to go with the model equals model. We're going to go with year equals year. Okay, now we can use this item to return self.items. We can then use the index that is passed to us. So imagine if we passed essentially an attribute name in here for Maya. So we want to use the rotate. We can essentially use that rotate because it now is coming through as a string to access this item. So now we can use my car and we can go open brackets. We want to get the make here, please. So again, it kind of gives us that little bit of functionality. It's really useful, actually. Okay, let's delete that. That's misleading. Okay, so let's change it to. So let's initiate the Tesla Model Y 2022, and let's get what is my car dot make. It's a Tesla. Okay, great. Well, what is the model? It's a Y. Okay, and the year. Okay, 2022. Easy. Okay, awesome. I'm going to save this example because the one I had is pretty pants. It was actually just using an integer series, but I don't think that's as useful. We've already kind of been using this car method, so we should probably just keep rolling with it. And that'll be a lot easier for us for context, essentially going forward, especially because we will be using, like we did earlier, we did material.a, and then we did, say, year. But this method uses a similar, instead of the get item, it uses the get attr. Sorry, this is the get item method we're using, but that was the get attr. Here we're using get item, which is this access. But let's look at the get attr now. This is just why I love Python. It's just too cool. It is just so flexible. Like, you point me in another language that has this kind of flexibility, essentially. So, all right. So now we've got get item and get attr. Let's essentially return self.items and index again. Okay, so it does the same thing. But let's say instead of doing year, I could using these extra 4 characters that we're typing here. So I'm too lazy for that. I want to just do .year. Okay, so I do, well, my car. Okay, .year. All right, let's have a little look. So the get attr. So this method is called when an attribute that doesn't exist, kind of like above. It doesn't have to exist, but essentially it's used more as an indexing. So, you know, it can do it's, again, it's used with the brackets. So get item is used as more of an indexing one, but we can repurpose it as we're going to do, okay, and use it for the purpose of getting an index maybe from a dictionary, okay, or as in Maya, we're going to use it for the attribute name. But you could also use this as the index like we did and said 1. And in the another way, we could then make items a list of our names. And we could say, well, 1 would then be, so we'd have, say, 0, 1, and 2. So we make our items into a list. Okay, and then we could use it like that. So you see, we're using our indexing methodology. That is what get item is specifically for, essentially getting the indexing value. Okay, but we're repurposing it and we're essentially cheating it to kind of work with a string index, okay, essentially, for our dictionary or for the items within our class. But the method is called, so the get attr method is called when an attribute that doesn't exist is accessed through an object. So you can return either an error saying it doesn't exist if you can't find it, okay, or you can return the requested attribute as we're going to do in Python and Maya. So if you remember the example I gave right before, then we're just going to literally add the get item, get attr to it. We're going to do .year. So this is how cool it is. So let's reinitiate our class. Okay, we now got get attr and get item. Then we're going to go .year. Let's see what it does. Oh, cool, isn't it? Okay, I mean, How amazing, how simple was that? That is what mainly we want to say. Okay, so car.make. Okay, it's given us a very easy way of getting a lot of very important attributes. And again, let's say you want to add more attributes to this. You would just go my car dot items. Okay, you want to add another item to it. We could go doors like we were talking about earlier. We could go equals 5. So we've just added that new item, okay, to our dictionary. So now we can also go doors in both of our get atter and get item. We've got 5 doors. Okay, you see our instance is getting more powerful essentially as we go through. What have I done? Whoops. There's no attribute doors. Interesting. So self.items. Very interesting. Okay, so the instance is coming through. What is going on there? So get item, get atter. So return self items index. So we got my car. Oh, was this initiated after? Ooh, okay. So, right. What we'll see here is my car that we're using. Okay, it wasn't reinitiated. So let's reinitiate everything here. All right, and now let's add the items doors. Okay, now we should press my car. Okay, we get the doors coming back, and now we go my car.doors, and we get 5. So again, just because quite simply our car class that was written out down here, again, this get atter, okay, was not essentially initiated before we added it. Okay, so we added it in the wrong order. We just had a little assignment error there, okay, for us. But okay, so that is get atter and get item. So that is how cool and very powerful they are. And I will add this example to our notes that you can then take out, and I'll make sure that those are updated to explain how they work. So let's move on. Okay, so we've looked at the string method. Let's have a little look at the left shift and right shift. These are pretty important. Essentially, okay, these methods here. Left shift and right shift. Okay, what do these do? All right, so these methods are called when the symbols, okay, these symbols are used. So the double left arrow, double right arrow symbols are used. Should be above your comma and your dot. So these are operators that can be used on an object, respectively. They should return a new object that represents the result of the shift operation. So if you remember the example I gave when I was telling you this tutorial, I use this method to essentially connect the attributes from one item or one object to another. Okay, it gives me a much more clear and readable way to do this. And otherwise I wouldn't really use it. But let's look at an example here. So we've got my integer, and we've got initiate, which takes a value, just one value, which is assigned to self.value in the instance of my integer. And then, okay, we are left shifting, and we're using the input value essentially and adding it to it, and returning self.value plus my integer. Let's have a little look at how this goes. So my int equals integer 8. And now let's see what we get output wise. That's it. I do want to. Now, I think this is something that I've done. Okay, writing this in a quick bit and a bit too quick the other night when I was tired. What essentially I'm doing is what we're saying here is that when we do an operation during a class, I'm using a different methodology in my head and I've written it out wrong. What we're going to be doing later on, though, is that when you create or do an operation within a class, what you should provide back is essentially a class-based object from that operation. But in this instance, the actual class that we want, or the type that we want, is just a simple integer, okay? Because we're just doing this simple operation. We wanted to return that. But for example, when we're doing an operation where we're adding two objects together, we want to return a class type of those objects. So that was my mistake there. We're just explaining the methodology to my madness. But now let's, okay, reinitiate, because we've just initiated my int with the old my integer. So that'll still be working with the old functionality. Let's reinitiate that. And then we'll print my int. Okay. So my int, again, left shift, so +2. So 8 plus 2, okay, equals 8. Sorry, equals 10. And again, okay, my int right shifted 2 equals 10. So what you could do, again, even with these, okay, because I'm doing essentially within my Pythonic system, I'm doing connect to the left. So I have an attribute here, and we can either say from this attribute connect to this one, or from this attribute connect to this one. But what you can do, again, is use these to say, well, for the left, we could do, for left shift, we'll go add to that. For right shift, we do subtract. So this will give us different outputs. So for now, the left shift, okay, we'll get 10. But now for the right shift, we should get 6. Okay, or minus, okay, we're giving a, so minus 2. So what are we getting here? Input value. Oh, of course, okay, my mistake. So we're not actually doing, we should be doing self.value, put the order around the other way, because obviously order is important. So we're now going to do that. Okay, and we're going to do self.value. Okay, I suppose, yeah, self.value minus, okay, the input value. All right, let's reinitiate. What we get is 10 and 6. Okay, so there's various different ways you can set this up. But you're seeing that, again, these having access to these symbols and allowing us to kind of work with these classes in this way, it makes makes Python very powerful for us. So let's use the add and subtract methodology to do these operations. Let's say, yeah, we're doing left shift, but actually we don't want to. So we can use the add and then subtract. Okay. Methods they are used to define how classes essentially should be added and subtracted from one another. So, okay, we can, like with our cars, again, we could maybe add our cars together. We could add the strings together. We could do certain methods that allow us. So let's say we've got an integer and it takes our operation and it does some fancy work within some other methods within the class. But what we can now do is go, well, my integer, and we can go my integer, and we can go plus 2. So it allows us to take our class, okay, and use the plus sign to work with it, okay? And you'll see what we've done there. We've just plussed essentially 2. We've just moved the functionality Pythonically outside of the class to make it more readable, human readable. But then we've put the complex workings of the class within the class. Okay, it's great. It's so much of a better way to work, isn't it? Okay. Okay, we're essentially allowing us to use classes, okay? Because now we could do, say, my int equals 8. Could do we'll do my int 1, we'll do my int 2. This one could equal 8, this one could equal 4. And then we could do my int 1, okay, plus my int 2. We could do the same, and we could go minus, okay? We could do it this way. So again, highlighting all, pressing Control Enter, and we go my int 1 plus. Interesting. Why are you not liking that? Let's have a look. So the input value again, because we've called the value. Actually, we've confused it a little bit because it doesn't know how. Because Python doesn't know how to interpret this value. It is just adding it, but okay, when it's being called. It actually just doesn't know what to do with it because this is a class, so you can't just add a class to a class. So what we can do for this instance is then go, okay, is do a little check. We could do an if is instance of self. We could then essentially check for dot value. So to make these both work, we could do if is instance of my integer, then handle it with dot value. Okay, and then that would essentially solve this problem. For now, I'll just skip the if is instance because we know it is. Okay, and then we'll just do it this way. Yeah, we get 12.4. So essentially, as I was saying, we could just do so if the input value of my integer and return that. And then if it's not, then hey, just do the standard operation that we talked about, okay? You don't need to do it plus value, okay? So it's going to return this, okay, and that will be the end of the function. And if it doesn't pass this, okay, it's going to run this, okay, and it's just going to go input value. So that's the way we handle that. So that's add and subtract. Really useful to be able to, again, put complex code, okay, start making classes, take care of each other, and be plus and minus to each other. Definitely I suggest looking at more examples on this, but we're going to be going into quite a few examples as we write our code out anyway for our nodal system. So, okay, let's skip down the nodes we've just done, add and subtract. But okay, I think these are mostly of the special methods that we're going to need essentially for our behavior, okay? Because we're going to start making our nodal setup, doing plus and minus. We'll do multiply. We'll also do divide, and we'll make it back compatible for Python 2. But that's pretty much all of the methods that we're going to need for everything we're going to work with later in Python. And I hope you're not being overwhelmed by these, because they are awesome and they provide such power to your objectification of all your Maya objects and of what you'll work with in the future. I generally try and apply this methodology to whatever I'm doing. I've done little contracts. Obviously before I had a family and a kid, I used to just do contracts, take 3 months off, do a 6-month contract here or there, do a year's contract. But then I'd generally take quite a few months off. I'd take 3-4 months off and just work on coding, working on tutorials. I used to love just buying Udemy tutorials for doing machine learning, for doing app development, and mostly, again, all in Python, just because it's fun and it was downtime for me. It was stuff to do, and it helped make me a better developer. I should have probably done some for public speaking. I apologize. But yeah, these are things that I've applied to app development and to methodologies within very different aspects of development, and yet they all reduce the code massively. So knowing about them will make you a better developer, trust me. But okay, let's look at common errors that you'll commonly come across with classes. There's quite a few. Let's list them out, start going through them. Thank you again for sticking with me with this. This is probably one of the most complex lectures we're going to go through. And I'm sure I'll get a few comments on this. And if, again, you need me to improve it, please be nice. But yeah, I will definitely work on that for you. If I need to do more detailed explanations, some more examples, please let me know. But okay, if not, just ask me some questions and I'll get back to you as soon as I can. Some common errors. Not properly initializing attributes in the initiate. Okay, like we've talked about, if you don't initialize them, then they won't be used. Okay, and you'll probably get an error because you're trying to pass a series of arguments. Okay, whether they're keyword arguments or positional arguments, you'll just get errors because your class doesn't know it's meant to accept arguments. So make sure you try to use your init. Okay, and practice with this. So overusing inheritance. We're going to be on the edge of this one with what we're doing because we are using 3 or 4 levels of inheritance. But it also becomes very obvious why we're doing it as we write it. And it abstracts the complexity from each layer to the next. Because as we've talked about with our dependency node, this is for objects without form and without any object type, okay, associated with them, without any shape, without any DAG node associated with them. Just try not to overuse inheritance because it just, again, makes readability difficult and it makes maintaining code difficult sometimes if you then have to look back through all the previous methods of what's happening, of why something's not working. So creating too many class level variables. Okay, these variables are shared across all inheritances of the class and can lead to unexpected behavior if not used correctly and carefully. So just try not to create too many, okay? Especially if you're not going to use them. There's no point in putting them in there if you're not going to use them, or they're never going to be looked at. So not following name conventions. Again, I'm going to keep on hammering this in. In Python, convention, it's best to use snake case convention for attributes and method names, and camel case for class names. Not following these conventions can make code harder to read for other developers. And again, this should only really not be adhered to for very consistent reasons within a whole framework. And as I've said, where best methodologies in Python exist. We are going to subvert these a little bit to follow the Maya practices, because obviously you don't want to be looking at one library within Maya and then working with a completely different methodology, and best practice in your own code. So annoyingly, okay, within our library here, we're going to use Maya's way, which is mostly camel case, which I'm not a fan of. I prefer the underscore because it separates everything. It's like a space. It makes it easy for us to read. But we're going to have to, some things we just have to do for ease going forward and essentially consistency with Maya. Overcomplicating code. Again, we can all do this. It's very simple. Okay, but classes should be designed to solve a specific problem, and they should not be overly complex. Overcomplicating code can make it harder to understand and maintain, and make it harder to run sometimes. Not using class methods or static methods when appropriate. We didn't go into these too much, but we're going to, we'll maybe come back to these, okay? But class methods and static methods make code more readable and easier to understand by clearly indicating the intended use of the method. Now, maybe go and look up static methods. We'll probably be going into these in a very small amount of way, but okay, we don't need them specifically for this course, so I'm not going to touch on them right here. But I'll probably in the notes point you to somewhere that these will be useful. These will be good to look at. Okay, I'll put a link in next to this common error essentially. Okay, so let's have a look. Not properly handling errors. Again, it's important to properly handle errors. Okay, in classes, same as functions, the same as everywhere. Otherwise, the code will become unstable and unpredictable. Make sure you handle them. Make it obvious to the user what they're doing, or the developer what they're doing wrong, so that they know how to fix it, so you don't have to then talk to them. As much as I love talking to people, I don't love repeating myself. I'd rather make it obvious what needs to be done. And that's not saying that people are stupid you're working with. That's saying more so that you're stupid for not understanding what someone new coming in, what their understanding of this network or this framework will be. Just because you're smart and you know your 100,000 lines of code, like again, it's a cool thing to know a huge library. I know mine and my library like the back of my hand because I work with it every day, and I've worked with it for the last 10 years plus. It's developed massively. But it would be stupid of me to assume that everyone I work with that has looked at my library and worked with my library understands where everything goes and what it's doing. Because there are some legacy piece of code I wrote 10 years ago, which I look back at and think, God, I've got to look at this and make sure I refactor it so I add it to my list. But you've got to make things understandable. So, and handle those errors, make it obvious for these people. So not properly using the repr and the str methods, okay? So the representation and the string methods, okay? These are special methods, magic methods, and they're used to provide a string representation of an object, and not implementing them correctly can make debugging and testing more difficult. So as we remember saying, this is just a string representation. So for the example that I use, okay, within our nodal system, the string method, it just returns a usable string of our object, okay? So that might just be the name of our object, of our DAG object. If we have a controller called arm IK1 control, okay, or upper arm control IK, or IK control, then it's good to return that name of that item. We don't need to return the name of that item plus different attributes of it, because then it's not usable. We want the string item to be usable and functional. But again, if we have a class representation of that control, we may then want to have it say, control, open parentheses, and all of the arguments that we use to create that control. Okay, that's more useful. So make sure you get these the right way around, because obviously then it's just annoying to people that come in, have to look at them and then go, wait, this should tell me how I need to access this. That's not what it's doing. And wait, this isn't giving me the string representation of this object. Why is it not doing that? That would be what's useful for it. Now, again, thank you so much. Okay, we've learned a lot. We've learned about classes. We've learned about attributes, methods, inheritance, special methods, and common errors. But thank you so much for listening, and I look forward to seeing you on our next video. Really well done to you guys. This is a hard stuff, okay? Congratulations. This is one of the hardest tutorials that I think we're going to go through essentially in our whole Python course.